Chapter 9.2, Solving Systems Using Elimination. Another way to solve systems algebraically is to use the elimination method. You can eliminate a variable so you can solve for a single variable. Elimination method. Always number your equations and put them in the same order before you start. Check that our equations are in the same order. In the first equation, we have the x value, then the y value, then the equal sign, then the constant term. We need the second equation to match that. We have the x value, then the y value, then the equal sign, then the constant term. So yes, they are in the same order. We'll label those equations 1 and equations 2. If they're in different orders, we would just move things from one side of the equal sign to the other by adding or subtracting so that they're set up the same way. Step 1. Make the coefficients of one of the variables the same, ignore the signs, by multiplying one or both of the equations. So right now we have 3x and 4x, and we have 2y and 5y. We want to make one of the variables have the same amount in each equation. So sometimes there'll be an obvious one that'll be easier. In this case, there's not. So just pick one of the variables that you want to work with. I'm going to go with y. I have 2y and 5y. I want to make those the same amount. So a multiple of both 2 and 5 is 10. How can I make the first equation have 10y? I would multiply everything in that equation by 5. The second equation, to get 10y, I would multiply everything by 2. So that is step 1. Then step 2, we write down what we get when we multiply. So 3x times 5 is 15x. 2y times 5 is 10y, so 15x plus 10y equals 2 times 5 is 10. 4x times 2 is 8x. 5y times 2 is 10y, so plus 10y equals 12 times 2 is 24. Step 2 says add/subtract the equations to get rid of the variable. If the signs on the coefficient are the same, you subtract. If the signs are different, you add. We have positive 10y and positive 10y. The signs are the same, so we would subtract. So we're going to subtract everything in the two equations. We can also check if we should add or subtract using our calculator. We have 10y. If we add 10y plus 10y, we get 20. It doesn't equal 0. We want it to equal 0 because we're eliminating the variable, so we're getting it to equal 0. If I do 10 minus 10, that gives me 0. So that tells me I need to subtract. So we're subtracting the x's, subtracting the y's, subtracting the constants. 15x minus 8x. 15 minus 8 is 7. So we get 7x. 10y minus 10y, that's 0. We don't write anything for that. And then 10 minus 24 is negative 14. Then step 3, solve for the remaining variable. So we now have the equation 7x equals negative 14. We can solve for x by dividing both sides by 7. 7 divided by 7 is 1. We get x equals negative 14 divided by 7 is negative 2. You can always use your calculator. X is negative 2. Step 4, substitute your answer into an original equation to solve for the other variable. We have the x value, we now want the y value. So substitute x equals negative 2 into equation 1 or equation 2 and solve for y. I'm going to go with equation 1, 3x plus 2y equals 2. X is -2, so sub -2 in. 3 times -2 plus 2y equals 2. 3 times -2 is -6, plus 2y equals 2. I want to isolate y, so add 6 to both sides. -6 plus 6 is 0. 2y equals 2 plus 6 is 8. 2 times y, we want just y, so divide by 2. 2 divided by 2 is 1. We get y equals 8 divided by 2 is 4. And then step 5, write down the ordered pair that satisfies both equations, and we can do a check to verify your answer. Our solution is the point -2, 4. And again, since we have the space, might as well verify. We're verifying the point -2, 4 in both equation 1 and equation 2. Equation 1 is 3x plus 2y equals 2. Replace x with -2 and y with +4, and calculate the left side. -6 plus 8. -6 plus 8 is 2 equals 2. So it works in equation 1. And then equation 2 is 4x plus 5y equals 12. 4 times -2 plus 5 times 4 equals 12. Calculate the left side. -8 plus 20. 12 on the right. -8 plus 20 is 12 equals 12. So that's correct. Therefore, we verified the point for the system. (2x minus 5y equals -1) and 3x plus 5y equals -14. We have the x's, then the y's, then the equals, and then the constants. So they're set up in the same order. We'll number them 1 and 2. Notice that we have 5y and 5y. So we already have the same number of one of the variables, so we can skip step 1. We're going to go right to step 2, where we either add or subtract. We have -5 and +5. We're going to decide if we should add those or subtract. We want them to add to 0. -5 plus 5 gives us 0. So that means we are adding all of the terms in the equations. So 2x plus 3x is 5x. -5y plus 5y, those add to 0. Then the equal sign, and then -1 plus -14. You can use your calculator. -1 plus -14 gives us -15. Step 3, we want to solve this equation that we got from subtracting for the variable that's left, which is x. We have 5 times x. We want x, so divide by 5 on both sides. 5 divided by 5 is 1. We get x equals -3. You can use your calculator again. -15 divided by 5 is -3. That's the x value of our solution. Now we need to determine the y value of our solution. Step 4. sub that x value into one of our two original equations, and solve for y. Doesn't matter which equation. I'm going to go with number 1 because it has smaller numbers. So 2x minus 5y equals -1. Replace x with -3. 2 times -3 minus 5y equals -1. 2 times -3 is -6 minus 5y equals -1. We want to isolate y, so add 6 to both sides. -6 plus 6 is 0. -5y equals -1 plus 6 is +5. -5 times y equals 5. We want just y, so divide by -5. -5 divided -5 is 1. We get y equals -1. 5 divide -5 is -1. Then step 5 is the solution, which is -3, -1. And again, we can verify, don't have to unless the question specifically says to verify, but we might as well. Verify the point -3, -1 in the system. That includes the first equation as 2x minus 5y equals -1. That gives us 2 times -3 minus 5 times -1 equals -1. 2 times -3 is -6. -5 times -1 is +5. -1 on the right. -6 plus 5 is -1 equals -1. Then equation 2, 3x plus 5y equals -14. 3 times -3 plus 5 times -1 equals -14. Calculate the left side. 3 times -3 is -9. 5 times -1 is -5. -14 on the right. -5 minus 9 is -14 equals -14. That's true. So we have verified the solution for the system. Nancy drove 310 kilometers from Calgary to Edmonton in 3.5 hours. She drove part of the way in the sun at 100 kilometers per hour and the rest in a storm at 60 kilometers per hour. How far did she drive at each speed? So the question at the end, how far did she drive at each speed? That tells us what our variables should be. We have two variables. I'm just going to call them x and y. So x, I'll say, is the distance driven at 100 kilometers per hour, and y is the distance driven at 60 kilometers per hour. This is a distance equals speed times time question. So we're going to make a table. She was driving in two conditions. First one is the sun, second one was a storm. The distances we don't know, those are our x for driving in the sun at 100 kilometers per hour, and then y for driving in the storm at 60 kilometers an hour. The speeds were 100 kilometers per hour for driving in the sun and 60 kilometers per hour for driving in the storm. And the times we also don't know, but in the distance equals speed times time equation, to solve for time, we would divide both sides by s. S divided by s is 1, so we get time equals distance divided by speed. Then under the time column, we write time for driving in the sun is the distance, which is x, divided by the speed, which was 100 kilometers an hour. And time for driving in the storm was the distance y divided by the speed, which is 60. We're given two other pieces of information that we haven't used yet. It says that Nancy drove 310 kilometers from Calgary to Edmonton. So the distances, x plus y, have to total to 310. Total distance is 310, and we're told that her drive takes 3.5 hours, so the total time is 3.5. Then our equations come from the distance column. The total distance is 310. That means x plus y equals 310. And from the time column, the total time is 3.5 hours. That means x over 100 plus y over 60 equals 3.5. When we have an equation that has fractions and we're solving by elimination, we usually want to try to get rid of the fractions. So if I have the same denominator, whatever denominator I have, I would multiply by that denominator, and that would make all the fractions go away. In this case, I don't have the same denominator, but I have one x and one y in equation 1. So I can multiply equation 2 by a number so that I end up with 1x or 1y, doesn't matter which one. If I multiply the equation by 100, I would get 100x divided by 100, which would equal 1x. Or if I multiply the equation by 60, I would get 60y divided by 60, which would give us 1y. So either 100 or 60, I'm going to go with 100. Then our two equations become x plus y equals 310, and 100x over 100 is 1x plus, we can use our calculator, 100 times y divided by 60, so 100 divided by 60, math, enter, enter, is 5 over 3, so 5 over 3y. And then 3.5 times 100 is 350. Then I have to decide if I add or subtract. I have positive 1y, positive 1. 1 plus 1 equals 2. That's not 0. So 1 minus 1 is 0. That means I need to subtract the x's, subtract the y's, subtract the constants. X minus x, those are gone. 1y minus 5 over 3, so 1 minus fraction 5 over 3 is negative 2 over 3y equals 310 minus 350 is negative 40. That was step 2. And multiplying the equation was step 1. Then step 3 is to solve the remaining equation, negative 2 over 3y equals negative 40. Negative 2 over 3 times y, we want just y, so we need to divide by negative 2 over 3 on both sides. Negative 2 over 3 divided by negative 2 over 3 is 1. We're left with y equals negative 40 divide fraction negative 2 over 3. That gives us 60. So y equals 60. Then we need to determine what x equals. Sub y back into one of our equations. Number 1 looks the easiest. X plus y equals 310. Sub in 60 for y. X plus 60 equals 310. Isolate y by subtracting 60. 60 minus 60 is 0. X equals 310 minus 60 is 250. And step 5, state our solution. It's a word problem, so state the solution in words. X was the distance driven at 100 kilometers per hour. So she drove 250 kilometers at 100 kilometers per hour. And y was 60 kilometers at, that was a speed of 60 kilometers per hour. Connor downloaded 2 orders of games and songs. The first order consisted of 5 games and 4 songs for $26. The second order consisted of 3 games and 2 songs for $15. All games cost the same amount, and all songs cost the same amount. Write a system of linear equations, then determine the cost of one song and the cost of one game. We want to determine the cost of one song and the cost of one game. So that tells us that our variables are S equals cost of one song and G equals cost of one game. Then each of the orders will represent an equation. The first order consisted of 5 games and 4 songs for $26. So we have 5G plus 4S equals $26. The second order consisted of 3 games and 2 songs for $15. That gives us 3G plus 2S equals 15. We need one of our variables to be the same in the 2 equations. I have 5G and 3G, and I have 4S and 2S. If I multiply 2 by 2, then it becomes 4. So if I multiply the whole equation, number 2, by the number 2, then I'm going to get the same number of songs. So that is step 1. Then step 2, the equations we now have are 5G plus 4S equals 26, and 3G times 2 is 6G plus 2S times 2 is 4S equals 15 times 2 is 30. We need to decide if we're going to add or subtract. We have positive 4S and positive 4S. If we add, 4 plus 4 is 8. not 0. 4 minus 4 is 0, so that tells us we're going to subtract each of the terms. 5g minus 6g is negative 1g or negative g. If you need to use your calculator for that, that's fine. 5 minus 6. Just make sure you write down negative g instead of writing g. 4s minus 4s is 0, so that's gone, equals 26 minus 30 is negative 4. Then step 3, we want to solve that equation from above, so negative g equals negative 4. That means negative 1g. We want just g, so divide by negative 1 on both sides. Negative 1 divided by negative 1 is 1. Then we get g equals negative 4 divided negative 1 is positive 4. Step 4, we want to solve for the other variable now. We have g equals 4. We want to sub that into one of our two original equations and solve for s. I'm going to go with equation 2 just because it has smaller numbers. So 3g plus 2s equals 15. G is 4, so 3 times 4 plus 2s equals 15. 3 times 4 is 12, plus 2s equals 15. I want to isolate s, so subtract 12 from both sides. 2s equals 15 minus 12 is 3. 2s means 2 times s. I want s, so divide by 2. 2 divided by 2 is 1. S equals 3 divided 2. In this case, we would change it to a decimal because we're talking about money per song, so 1.5. And then step 5, write our solution for a word problem. We're going to write a statement. S and G are the cost of the song and the cost of a game, so each game costs $4 and each song costs $1.50. And since we have space, we might as well verify. Equation 1, 5g plus 4s is 26. 5 times 4 plus 4 times 1.5 equals 26. Calculate the left side. 5 times 4 is 20. 4 times 1.5 is 6. You can use your calculator. 20 plus 6 is 26 equals 26. Equation 2, 3g plus 2s equals 15. 3 times 4 plus 2 times 1.5 equals 15. 3 times 4 is 12. 2 times 1.5 is 3. 12 plus 3 is 15 equals 15. So we verified our solution for the system. At Eliza's printing company, there are two kinds of printing presses. Model A prints 70 books per day, and Model B prints 55 books per day. The company owns a total of 14 printing presses. They can print 905 books per day. How many of each type of printing press do they have? The question, how many of each type of printing presses do they have, tells us our variables. A equals number of printing press A. and B for number of printing press B. Then we have Model A prints 70 books per day. Model B prints 55 books per day. The company owns a total of 14 printing presses, and they can print 905 books per day. We need to write two equations with that information. I'm going to start with they have a total of 14 printing presses. A is the number of printing press A, and B is the number of printing press B. So A plus B has to equal 14, since that's how many printing presses they have. That can be equation 1. And then equation 2, Model A prints 70 books per day. Model B prints 55 books per day, and they can print a total of 905 books. So 70 books per day times the number of Model A we have, plus 55 books per day times the number of Model B we have, equals 905, the number of books they can print in a day. That would be equation 2. We need one variable to be the same in both. So if I multiply equation 1 by 70, I would get the same number of A. Or if I multiplied equation 1 by 55, I would get the same number for B. So either one of those, I'm going to go with 70. Our new equations are 70A plus 70B equals 70 times 14, which is 980. And then 70A plus 55B equals 905. Then should we add or subtract the equations? 70 plus 70 is 140. We don't want that, we want 0, so 70 minus 70 is 0, which means I need to subtract each of the terms in the equations. 70A minus 70A is 0. 70B minus 55B. 70 minus 55 is 15. So 15B equals 980 minus 905, which is 75. Step 3, solve that equation that we just got. 15B equals 75. Isolate B by dividing both sides by 15. 15 divided 15 is 1. We get B equals 75 divide 15 is 5. Step 4, use B equals 5 to solve for A. Equation 1 looks easier to solve, so A plus B equals 14. A plus 5 equals 14. Subtract 5 from both sides. A equals 9. Then step 5, state the solution. They have 9 of printing press A and 5 of printing press B. Stu spent $131 on shirts. A long sleeve shirt cost $28 and a short sleeve shirt cost $15. If he bought a total of 7 shirts, how many of each kind did he buy? So that part, how many of each kind did he buy, tells us our variables. L equals number of long sleeve shirts, and S equals number of short sleeve shirts. The information we're given is that Stu spent $131. A long sleeve shirt cost $28. A short sleeve shirt cost $15. And he bought a total of 7 shirts. So 2 equations. First equation, he bought a total of 7 shirts, so the number of long sleeve shirts, L, plus the number of short sleeve shirts, S, equals 7. Second equation, he spent $131. A long sleeve shirt cost $28, so 28L plus a short sleeve shirt is 15. 15S equals 131. Multiply the first equation by either 28 to make the L's the same or 15 to make the S's the same. Either one is fine. I'm going to go with 28. Step 2, my equations become 28L plus 28S equals 28 times 7, which is 196. And then 28L plus 15S equals 131. Should I add or subtract? 28 plus 28 is not 0. 28 minus 28 is 0. So I need to subtract all of the terms. 28L minus 28L is 0. 28S minus 15S. 28 minus 15 is 13S equals 196 minus 131 is 65. Step 3, solve that equation. 13S equals 65. Divide both sides by 13. We get S equals 5. Step 4, solve for the other variable using S equals 5 and one of our original equations. Number 1 is definitely easiest. L plus S equals 7. L plus 5 equals 7. Subtract 5 from both sides. L equals 2. And step 5, state the solution. Stu bought 5 short sleeve shirts and 2 long sleeve shirts. And this is the last one, might as well check it. We've got the space. Equation 1, L plus S equals 7. 2 plus 5 equals 7. 2 plus 5 is 7 equals 7. Equation 2, 28L plus 15S equals 131. 28 times 2 plus 15 times 5 equals 131. 28 times 2 is 56, plus 15 times 5 is 75, 131 on the right. 56 plus 75 is 131, equals 131. So we verified our solution for the system. So now that we've gone through both substitution method and elimination method for solving systems of linear equations algebraically, I am happy to inform you that you need to be really good at one of these methods of solving algebraically. On your quiz and your test, you will be asked to solve algebraically. You will not specifically be told to use one method or the other. So get really good at one of these two methods, and whichever one you use is fine with me. And that brings us to the end of the Chapter 9 notes.